Hey guys, welcome to the video for quadratic transformations. We're in Unit 7a. Our essential question is, how is vertex form related to transformations from the parent function? So our essential question has a couple of things in there that are key for this lesson. First, it talks about vertex form. Well, that's something that we already know. And then it talks about transformations. Now, transformations we saw in Unit 4 with lines. And then we see parent function. Well, what's a parent function? Well, the parent function for any function is the most basic of that function. So for example, if I write this equation, y equals 3x plus 1, this is going to be a line because I have a slope and a y-intercept. But what's the most basic line I can create? That's going to be y equals x. I don't have any numbers, nothing fancy going on, right? That's the parent function. The parent is the original, and then all of the children come from it. So this would be a child of the parent function. Now, we're in quadratic, so we're not in lines anymore. We're with parabolas, right? So, for example, if I give you y equals 3x squared plus 2x minus 5, well, this is in standard form. There's a lot of stuff going on. What makes this a quadratic? Remember, a quadratic is a second-degree polynomial, right? So if I don't have that 2 there, I just have a line, technically. So if I have the 2 there, then it makes it a quadratic. So what's the most basic quadratic I can make? Well, y equals x squared. There's nothing fancy, no numbers, nothing, right? There's nothing really going on with that. So the parent function is the most basic function you can make. So I want to go ahead and talk about, remember, the linear parent function is y equals x. It's just goes through 0, 0, nothing much going on. Now, if I square that, then it becomes a quadratic, okay? So if I don't have a 2, I don't have an exponent of 2, it's just a line, okay? So like earlier, I had 3x squared plus 2x minus 5 or whatever. That's a quadratic, but once I get rid of the 2 over here, the exponent, I just have a line, right? If there is no square, it's not a quadratic. All right, so back in Unit 4, we did see transformation. So for example, we would graph the original parent function for a line, f of x equals x. Okay, and then you would transform that line. So g of x equals f of x. Now here I haven't done anything, right? I said f of x equals x, and then I set g of x equal to f of x. So there's nothing fancy going on. Well, do you remember, if I do something to that green line, remember the green is the new one. Let's say I add 2 to it. Well, what happened to my line? Well, it was at 0, 0, and now it's at 0, 2. I have shifted my line up 2 units. Well, how could I shift it down 2 units? Well, if I put minus 2 on the outside, it makes it shift down, okay? Now, do you remember what goes left and right? Left and right is on the inside of your parentheses, right? So on the inside, if I wanted to make it go left, okay, what would you think? Would I do, let's go left 3. So if I go left 3, would I add 2 or subtract 3 or add 3, right? If I want to go to the left 3. Remember, when we're in the parentheses, it's always opposite, okay? If it's opposite, then if I want to go to the left 3, then I would add 3. So I start at 0, 0, and I move it to the left. The blue is the original, the green is the new. Now let's say I want to go to the right. If I want to go to the right 3, then I would subtract 3. So I start at 0, 0, and I shift it over to the right 3 by subtracting. So it's opposite. The quadratics are very similar. So if I have f, I don't know why I erased all that. Let me put all that back. Okay, we're going to get rid of this though. Okay, so let's do x squared. So now, instead of a line, I have my quadratic, right? The blue is the original, the green is the new. Well, if I wanted to shift this to go up 2, I would add 2. Do you see how my quadratic got shifted up 2? Well, if I wanted to go shift it down 2, I would put minus 2, okay? If I want to go to the left 2, I would go inside the parentheses and add 2 because it's opposite. If I want to go to the right 2, I would subtract 2 in the parentheses. So we're doing transformation with quadratics essentially. And the whole basis is that we're using the parent function, that blue graph. We're using that as our basis, right? We're saying that that's the original, and now I'm going to do a bunch of transformations from this original. Okay, now let's get started with the notes. Vertex form. Now we learned vertex form, that is y equals a parentheses x minus h parentheses squared plus k. And the vertex is h comma k. Now, when we talk about transformations with quadratics, right, we're going to be using vertex form. So that's going to be the best form for us to do quadratic transformations with. So here I have transformations in vertex form, and I have wrote out the vertex form very largely. Now, I split this into 4 sections because there's 4 sections of this that we need to remember. I'm going to go ahead and start with the hardest part first, which is the A value. Now notice how A has 2 arrows coming out of it. It's because the A value is going to tell me 2 things, okay? It's going to tell me whether or not I have a reflection and whether or not my quadratic is going to get narrower or wider, okay? So normally we would get the A value and you would be like, oh, if A is positive, it would open up, and if A is negative, it opens down, right? So the important thing is, oh, whoops, I put back, oh, there it goes. Okay, so the first thing I want to mention is if your A is negative, what happens? Well, it opens down, right? And that's not new, that's something we know. It's going to make a downwards parabola, and remember it's negative with a sad face. If this is the case, right, if it opens down, there's a reflection happening. So I'll show you what I mean. This is a normal parent function parabola. If I wanted it to be going facing down, what does my A value have to be? Well, it needs to be negative, right? Do we see that putting the negative in the front makes it go down? Well, what kind of reflection is this? What axis is it reflecting over? Is it reflecting over the x-axis or the y-axis? It's reflecting over the x-axis. So if there is a negative, it is a reflection over the x-axis, okay? So if there's a negative in the front, it's going to be a reflection over the x-axis, regardless of whatever number is there. If there is a negative sign, it is a reflection. So we're giving it a specific name instead of just saying it opens down. We're saying it's a reflection over the x-axis. The second thing the A value tells me is whether or not my parabola gets narrower or wider. So I'm going to write down 2 different functions here. So I have g of x equals, whoops, there's no parentheses there, g of x equals f of x. So I'm setting them equal to each other. There's nothing fancy going on here yet. Okay. Now, how could I make this narrower? Well, let's say I multiply and put a and make it 2. What do you notice? The blue is my original, the black is my new one. Did it get narrower or wider? It got narrower. Well, what if I multiply by 5? What happens? Narrower. Let me go ahead and write it in a way that might look a little bit easier for us to understand. Let's say g of x equals x squared. So notice g of x and f of x are exactly the same. I've set them equal to each other. Okay, but let's make a in the red one 3. If I make a 3, what happened? It got narrower. What if I make it 7? It's even more narrow. What about 10? Narrower. What about 100? Even more narrower. So what do you notice as my numbers are going up? As my numbers are going up, my parabola is getting narrower, right? So if I put 3, it's narrow. If I put 32, even more narrow. 320, more narrow. So the bigger the number, the more narrow. Now, does multiplying it by 1 do anything? No, right? Because 1 is the normal A value. Now, what if I put 1.5? That's bigger than 1, and it did get narrower. What about 1.9? So anything bigger than 1 is telling me that it's narrower. So if A is greater than 1, okay, it's going to make it narrower. But there's a specific math term we use for this, and that is called a vertical stretch. Now that's going to be very hard for me to demonstrate for you, especially because I'm using an iPad and you can't see me. So I'm going to try my best to demonstrate this. So narrow means vertical stretch. You don't have to write this part here, but I'm going to draw this picture to help demonstrate what I'm trying to talk about here. So this is my parabola on my graph. Now vertical stretch means I'm stretching it vertically. Well, which vertically means up and down, right? So if it's up and down, which axis am I talking about? Well, I'm talking about the y-axis here, okay? Let's say I stretch it and I pull this and I pull that. And I pull the y-axis up and I pull it down at the same time. Well, what's that going to do to my parabola? What's it going to do to this? Well, it's going to make it shrink in and become more narrow and get closer, right? Because you're making it tighter, right? If I stretch it and I pull it, my parabola gets tighter and more narrow, okay? Now I'm going to leave this picture here because we do need it for the second part. So if my A value is bigger than 1, just like I showed you, if A is bigger than 1, like 5, right, it's going to get more narrow, which is called a vertical stretch. Now, what happens if A is less than 1? Okay? And what I mean by less than 1 is I mean between 0 and 1. So if A is in between 0 and 1. Okay, let's go test that out. Now, I want to tell you something. Negatives tell me a reflection. It has nothing to do with making it narrower or wider. Okay, I'm going to say that one more time. A negative A value, like if A is negative, it has nothing to do to make it wider or narrower. For example, here I have x squared and here I have negative x squared. They are the same wideness, right? Negatives have nothing to do with narrowness. The number that is attached to the front is what affects to it though. So if I have negative 2, the first thing I notice is 1, it's a reflection. But the second thing is if I put a 2 there, it's going to get more narrow. Okay, so those are two separate things. They both are each doing something different. Okay, so the A values have something different with just the number itself and then whether it's negative or not. So let's say our A value is between 0 and 1. So I am talking about a fraction decimal in between 0 and 1. So let's say 1/2. Let's multiply this by 1/2. What happened from going from blue to red? It got wider. What happens if I make it 1/5? Even wider. 1/10? Even wider. What about 1/100th? Super wide. Do we see that? So any number that's smaller than 1 in between 0 and 1, it's going to make it wider. So if I had 0.5, wider. 0.9, it's wider, but just barely. You see how the red is barely wider than the blue? So it is wider, but you can barely notice it. So this number, if it's between 0 and 1, is going to make it wider. This is known as a vertical compression. And I'll explain what that means. Okay? Remember, vertical means I am going on the up and down axis. So I'm talking about my y-axis. If I compress this, if I push the y-axis towards itself, so I grab the top of the y-axis, and then I grab the bottom of the y-axis, and I squish it, I compress it. Well, what's going to happen to my quadratic in here? Well, if I squish it, it's going to get wider, right? Because I'm compressing it. So it's going to flatten out. So that's what a compression means. So vertical compression means it's going to flatten out that way. Okay, so that's what vertical compression and vertical stretch mean. And I am going to use both of those terms in these notes. Okay, moving on to the easier ones, which are H and K. Now here, I'm inside the parentheses, right? Inside the parentheses is going to be a horizontal shift. Now, which directions are horizontal? Well, that's left and right. So this is going to be either in the left direction or the right direction. So just like I showed you in the beginning of the notes, if I'm inside the parentheses, I'm going to either go to the left or go to the right. But the thing you have to remember about this is that it's opposite signs. It's opposite of what you think it is, right? So for example, if in the parentheses I have x plus 3, right? If I have plus 3 on the inside, I want to think right 3, but I want to think the opposite and do left 3. Okay, so it's opposite of what you think. If I have x minus 5, that's going to be to the right 5. Again, it's opposite of what you think. Okay, and lastly, we have our k value. Now, that's the last thing we have, which is going to be the vertical shift. And vertical direction is either up or down, and it's exactly what you think it is. So you're either going up or you're going down depending on your k value. Okay, so let's review all of our transformations. Again, I spent a lot of time on this because this is the part we struggle with the most. It's just identifying things. Remember, your A value tells you two things, whether you have a reflection or whether you have a stretch or compression. If there is a negative sign in the front, then you know that there's a reflection over the x-axis. If there's no negative sign, then there's no reflection. If your A value is bigger than 1, it's going to become narrower, okay, also known as a vertical stretch. If your A value is between 0 and 1, so a fraction or decimal in between, it's going to be a vertical compression and get wider, okay? Negative signs do not reflect narrowness and wideness, okay? So it has nothing to do with that. Okay, inside the parentheses, you're going either left or right, and it's opposite. And if you're on the outside of the parentheses, adding or subtracting, then it's either up or down, exactly what you think it is. So we're going to practice down here. Okay, so we're going to do number 1 first. Identify the vertex and axis of symmetry and describe the transformations. So in number 1, what's my vertex? Well, this is vertex form, so my vertex here is going to be +4, +3. Remember, H is opposite. That means my axis of symmetry, well, it always starts as x equals, and it's going to be the 4 because it's the x value. All right, so let's go ahead and start identifying our transformations. So you want to start going left to right. So you always have y equals. Well, the first thing I run to is a +2. So right off the bat, there is no reflection happening here, okay? But does my narrowness, or does my graph get narrower or wider because of that 2? Well, remember, the normal parent function has a equal to 1, okay? So is 2 bigger than 1 or less than 1? It's bigger than 1, right? So if 2 is bigger than 1, if the a value is bigger than 1, what happens? Well, my parabola gets narrower. It's a vertical stretch. Okay, it gets narrower because of that a value being 2. Then the next thing I see is the x, but that's pretty normal. And then I see -4. Well, -4 in the inside the parentheses tells me I'm either going left or going right. But you want to think opposite, so this is going to be right 4. Okay? The next thing I see is the square, right? The 2 exponent, but that's normal. And then I see +3. Right? So you're basically identifying anything that's not x and not the square. And then I see +3. Well, +3 is on the outside, so that's either up or down, but it's exactly what I think it is, so it's going to be up 3. So in this quadratic, I have 3 transformations going on. It's going to be narrower than the original parent function, it's going to be to the right 4 of the parent function, and it's going to be up 3. Okay, moving on to number 2. The first thing I'm going to identify is the vertex. Remember that is HK. So our vertex here is -2, -1. Our axis of symmetry is x equals -2. Now this is not new to us, so I don't want to spend a ton of time talking about that. The first thing I notice on this one is, well, as I go this way, left to right, I notice that there's a negative sign here. Well, what do negative signs tell me? That I have a reflection over the x-axis. It's going to turn my quadratic and face it down. Okay? Now, does my quadratic get wider or narrower because of that negative? It doesn't, right? The negative has nothing to do with the wideness or narrowness. What is your a number here? The a number is +1. Well, +1 doesn't change, or not, well, +1. 1 does not change anything, right? I showed you that if I multiply by 1, it's not going to change anything, right? If I put a 1 in the front, it literally does nothing to the blue graph. If I do -1, it flips it across the x-axis because it's a reflection, but does the 1 have anything to do with that? No, right? It has nothing to do with that. So the wideness and narrowness is not affected here. The next thing I see here is the +2, and that's going to tell me left 2. And then the last thing I see is, did I do this out of order in color? Oh, I did. That's going to bother me. Let me fix that. Red, and then the last part is green. Okay. Which means I need to change this. I'm so sorry. The next thing I see is the -1, which means it's going to be down 1. Okay, so that's just identifying the transformations. Okay, so now we're going to start with graphing the transformations. Now, graphing the transformations is not that big of a deal. For the first one, I'm going to show you compare it to the parent function, but for the other two, you don't really need to graph the parent function. So let's review what parent function is, right? The parent function, a parent function, is the most basic function. Now, the parent function for a quadratic, again, is the most basic, which is going to be f of x equals x squared or y equals x squared. Okay? Now, I want to show you in comparison of what we're really doing here, okay? Now, I'm going to graph this on this graph right here. So in order to graph any quadratic, I need my calculator so I can type in my table, right? So I'm going to type this in my calculator, y equals x squared. I'm going to type it in the y equals screen. And then I'm going to get a table. I go to second graph and I go to my table. And I'm looking for the number that has no twin, the center of my rainbow. And I get 0, 0. Okay, now I'm not doing this part because you should know how to graph by now. And then I get 1, 1 and 2, 4. Okay, those are my other two numbers below, and then the two numbers above are negative 1, 1 and negative 2, positive 4. So those are my table values. Again, if you're having trouble getting those table values, we have a bigger issue at hand. Please come see me for tutoring. So at this point, we should know how to graph. So I'm going to go ahead and graph that parent function on the first graph. So negative 2, positive 4, negative 1, positive 1, 0, 0, 1, 1, 2, 4. Okay, I'm graphing the parent function. Remember, that's the original function is what we're basing our entire transformation process off of. We're basically taking this purple graph and we're going to do stuff to it. Okay. Now, before we even begin, I can actually list the transformations of this equation without even having to graph it. So, what's the first thing I notice about this quadratic? Well, what's my a value here? It's positive 1. Does 1 do anything to my graph? It doesn't reflect it, and it doesn't make it narrower or wider. So the 1 has nothing to do with anything. The first thing I see then that's really important is the plus 1. Well, that's going to make my graph go to the left 1. Remember, it's opposite. And then the next thing I see is the plus 2, which is going to be up 2. All right. So now I'm going to graph that equation in my calculator. Y equals x plus 1 squared plus 2. So in my y equals screen, I'm going to type this equation in there, and then I hit second graph to go to my table. Okay? In my table, I'm looking for the center of the rainbow that doesn't have a twin. Now, without even graphing this, I already know what my vertex is going to be. It is going to be negative 1, positive 2. How did I know that? Because vertex form tells me what the vertex is already going to be. Excuse me. So the two numbers below that, I actually need to type this in because I do not know. The two numbers below that are going to be right after the vertex. Squared plus 2. Scrolling in my calculator. So that's going to be 0, positive 3, and 1, positive 6. The two numbers above that are negative 2, positive 3, and negative 3, positive 6. I'm going to go ahead and graph this equation on to my current graph with the purple one already there. So I have negative 3, positive 6, negative 2, positive 3, 0, 3, oh sorry, not 0, 3, negative 1, negative 2, 0, 3, and 1, positive 6. So that's my new quadratic. That's the one that I have graphed here. Okay, it's my new equation. Do we see that the purple and the blue are not the same? Okay, they're not the same because we've transformed it, right, from the original. The purple is the original, the baby blue is the new. Well, you're like, I still don't understand what's going on here. Well, the two transformations that are happening here are we're going to the left 1 and up 2. So I want to show you something kind of cool. Okay, let's start at this point 0, 0, right? The parent function always starts at 0, 0 for quadratics. So let's do the first transformation. It says left 1 and then up 2. Well, let's move this orange point to the left 1, so here, and then up 2. And then plot that point. And then let's move this point. Left 1, up 2. What about this point? Left 1, oh sorry, that's not, left 1, up 2. Do you see that we're doing exactly what the transformations are? Let's do this one. Left 1, up 2. With this one, left 1, up 2. So that's basically what's happening here is we're transforming our parent function and creating a new function. Now, am I going to have you graph the parent function on every graph? No. But I did it in this case to show you what's really happening here, okay? Again, I am not going to make you graph two of them at the same time. I'm just showing you that, hey, this is what's happening. I just want to let you know that this is happening so that you are aware of what is happening, okay? All right. So, moving on to number 2. The first thing I'm going to do is I'm going to identify my transformation since I can do that without graphing it. The first thing I notice is the negative sign. Remember, negatives tell me that I have a reflection over the x-axis. okay? I have a reflection. Remember, reflection over the x-axis. Doesn't tell me anything else, just a reflection or not. Now, what's my a value here? It's just 1. So does my narrowness or wideness change? No, because in the parent function, a is 1. So nothing has changed about what my a value is. So there is no stretching or compression. There is no wideness or narrowness changing here. So the next thing I see is the -2. That means I'm going to the right 2, because it's the opposite of what you think, right? It wouldn't be left 2. Remember, right and left are on the inside of the parentheses. And then the last thing I see is the +3, which tells me I'm going to go up 3. So all 3 of these transformations take place from my original parent function in the purple. I'm not going to graph the parent function on this one, but I do want to show you that, or I did want to show you that that's what we're doing here. So all I'm going to do is just graph this. So the graphing part is nothing new. It's just identifying the transformations is the new part for us. Okay, so let's go ahead and graph this. I have my table. I want to type that into y equals, right? But without even graphing it in my calculator, I already know what my middle point is, my vertex. It is going to be +2, +2, right? Well, again, it's opposite sides in the parentheses. And I already know my oh, not 2. I copied that down wrong. You're probably thinking I'm crazy over here. It should be a 3. +3. So that means my vertex is +2, +3. Copy that down wrong. Okay, so I'm going to type that in y equals negative, parentheses, x minus 2, parentheses squared, plus 3. Remember, the first sign here is a negative sign. And this is a minus sign. So it's very important that you type those exactly like those, because if you make them both negative, it messes things up. Okay, so 2, 3 is my vertex. The 2 numbers below that are 3, 2, and 4, -1. And then the 2 numbers above 2, 3 are 1, 2, and 0, -1. Remember, these should always match each other. And if they don't, then you might have wrote your table down wrong. Okay, so we're going to plot this. 0, -1, 1, +2, 2, +3, 3, +2, and 4, -1. All right, so this is our new quadratic. Now, I could have graphed the original parent function, right? I could have graphed this, my original over here, right? I could have graphed it to use it as a reference, but I don't need to, right? I'm not going to make you. I just wanted to show you what was happening in number 1. All right, going on to number 3. Now, this one I do have a star next to, because does it look like it's in vertex form? No, right? Because vertex form has parentheses. So we'll be like, okay, well, that doesn't even look like vertex form. What is this? It looks like standard form, right? But it is in vertex form. It's just in disguise. And I'll show you what it's disguised as. Really, let's use pink. It's actually y equals 1/2 parentheses x minus or plus 0. -0 plus 0, not a big difference. -4. So why do you think they didn't write the parentheses here? Well, does adding 0 to x change it? No, right? It's just going to be x. So the reason why they didn't even bother putting parentheses was because the 0 is not that important. Okay, but regardless, they're the same exact form. So let's identify our transformations here. Okay, so the first transformation I see is the 1/2 in the front. It's not negative, so there's no reflection, but I have a 1/2. Now, 1/2 is the a value. Remember, the a value tells me whether it's either going to be narrower or wider. So is 1/2 bigger than 1 or less than 1? It's less than 1. It's actually in between 0 and 1. Because it is less than 1, it's going to make my quadratic wider. Also known as a vertical. Do we remember which one? Let's think about it. Right, if I have a quadratic like this and I do a vertical, I want to make it wider. Would I compress it or stretch it? I would compress it, right? I would squish my y-axis. I would take the top, take the bottom, squish them, grab this end, and squish them towards each other, and then it would make my quadratic even wider. It would flatten it out. So this is going to be a vertical compression, also known as making it wider. All right. The next thing I see is the 0, but does going left or right 0 really that important? No, it didn't really move anything. So the plus 0 in the parentheses doesn't really matter to me. And then I have the -4. Well, the -4 is on the outside of the parentheses, so that means I'm going to go down 4. Again, I don't want to say that I'm going left 0 or right 0 because that's not really that important. Okay, now I'm going to put this in the calculator. Y equals 1/2 x squared minus x. You can also type in the pink in the calculator, but you'll get the same exact thing when you go to your table. So, I have my table here, right? Do I know the vertex of this before even graphing? Well, yeah, I do because I wrote it in vertex form up here. My vertex is going to be 0, -4. Okay? And I can prove it to you in my handy dandy calculator. And I'm using my old school calculator, so it's not the best here, right? Right, it's not those fancy ones that I normally use, but I'll show you what I have. Now, there's a star next to this problem because the vertex form is not explicitly shown, but there's also a star because we will get decimals and fractions and such when we do our table. So I'm going to show you my calculator. Again, it's my old school one. So I do 1/2 x squared minus 4, second graph for my table. Now, I already know my vertex is 0, -4, right? You see how that's the middle? Because these are twins and these are twins, right? These are twins with each other and these are twins. So 0, -4 is the center. Notice how I have decimals, okay? So the two bottom numbers in my table, or the two numbers below are going to be 1, -3.5, and then 2, -2. The two numbers above are -1, -3.5, and -2, -2. Okay, so I'm going to plot all these points. -2, and then down 2. Now, -1, and then -3.5. So I'm going -1 to the left, and then I'm going to go down 1, 2, 3, and then go down 0.5. So I'm going to be here. Okay, so that's -3.5. And then I have 0, -4, and then I have 1, -3.5. So I'm going to go to the right one, and then go down 1, 2, 3, and then down 0.5. Because it's -0.5. And then I have 2, -2. So, do we see that the quadratic is a little bit wider than what we normally have, right? It's a little bit more open, right? With the other quadratics here, when the wideness didn't change, it's kind of like a V-looking thing. But here, we can tell, okay, it kind of looks like a bowl now. It's a little bit more wider. And should it have been wider? Well, yeah, because I had the 1/2 in the front. All right. Now, beginning with the second part of the notes, it's just basically taking equations and being able to recognize, well, can I transform this? And also, do I know the difference between wideness and narrowness? Okay, so let's start with this one. Given y equals 3x minus 1 squared minus 5, create an equation that has been reflected over the x-axis, vertically stretched, shifted left 3 units, and down 2 units. So here, we're not basing this off the parent function. We're basing it off of a function that currently exists. The function that currently exists is this one, okay? So I'm going to go ahead and write that function down. Y equals 3x minus 1 squared minus 5. So again, we're not basing it off the parent. We're basing it off of this one, okay? The first thing it wants me to do, if I read this, it says create an equation that has been reflected over the x-axis. That's the first thing it wants me to do. Well, to reflect something over the x-axis, what makes a reflection? Reflections are caused by negative signs. So I have y equals and then a negative. Okay, and let's keep going. Let's see what else I need to keep adding on. The next thing it says is to vertically stretch it. So does vertically stretching it make it more narrow or wider? It makes it more narrow. Okay, vertically stretching it, I'm pulling on the y-axis, so it would basically stretch out my parabola and make it really tiny, right? Okay, so if I'm vertically stretching it, that means I need a number bigger. Well, what is my a value currently? Well, my a value currently is 3, right? It is 3. If I want to stretch it and make it even more narrow, I got to pick a number even bigger than 3. Well, I can pick any number bigger than 3. I can pick 5, I can pick 7, I can pick 1,000 if I wanted to. Let's go ahead and just pick like 8 or something. So let's pick 8. Okay, so I'm vertically stretching it, so I'm picking a number bigger than 3. Okay, so remember, the bigger the number, the more stretched it's going to be. So for example, this is my normal, right? If I put a 3 in the front of the red, it gets narrower than the blue. If I put a number even bigger than 3, it gets even more narrow, right? If I compare 3 and 8 with each other, the red one is more narrow because A is bigger. So the bigger the number, the more narrow it is. So you could pick 4, 5, 6, whatever. Okay, the next thing I have is a parentheses. Let's keep reading because we don't know what we need to do next, right? The next thing it says is shifted left 3 units. Well, if I'm shifting something to the left, that's going to be in the inside of my parentheses, right? Now, shifting to the left, I would do the opposite of what I think. So normally left, I go minus, but really with transformations, I want to do plus 3, right? Because it's left 3. Well, I would have to add it on to what I already have. Remember, we're using the function that we already have, not the parent. So right now, it is to the right 1, currently, because it's minus 1. I need to shift it to the left 3. Well, what's negative 1 plus 3? That's going to be positive 2. Okay? So again, we're shifting it left from where it currently is. Currently is at to the right 1. And if I shift it to the left 3, it's just going to be at the left 2. Okay? So we're adding it onto what we already have. So for example, if this said I needed to shift it to the left 5 units, right, I would add 5, and I would get positive 4. Okay, so that's what you want to add it onto what you already have. Okay, the next thing I see is down 2 units. Well, shifting something down is going to be on the outside of my parentheses. Well, that's going to be where this minus 5 is from. I want to shift it down from where it currently is. Right now, it's already down 5, and I got to shift it down 2 more. So what's negative 5 minus 2? Negative 7. Okay, so that is going to be our new transformed equation. We started off with the original, and now we have something brand new. So this is our new quadratic transformed from what it was. Okay, now remember that red number, that 8 can be anything as long as it's bigger than 3. If I wanted to make it vertically compressed or wider, I would pick something less than 3, right? So I wouldn't want to pick 2 in this case because I wanted it to be narrow. If I pick 2, then it's actually going to be wider than the original. All right, and then the very last problem is order the parabolas from widest to the most narrow. Remember, wider means that my A value is going to be in between 0 and 1, right? It's a decimal or fraction, whatever it may be, between 0 and 1. If it is narrow, it's going to be a number bigger than 1. Okay, so the bigger the number, the more narrow. The smaller the number, the more wide it's going to be. Now here I notice I have some fractions, and I don't even know what those numbers are yet, so let's go ahead and make those into decimals. Now I'm going to start over here first though. Here my A value is negative 4, but do negatives indicate to me whether I have wider or narrower parabolas? No. Negatives tell me reflection. It has nothing to do with wideness or narrowness. So here all I want to notice is the 4. So I notice that A is equal to 4 here. A is 4. Okay? The second one, our A is 2. Again, the negatives doesn't really matter. I'm just looking at the number itself. Remember, negatives are just reflection. It doesn't tell me the wideness or narrowness. I know I've said that like 500 times in this video, but I'm stressing it because it's something we struggle with. Now, 2/3. Now, I want you to type in 2 divided by 3 in your calculator. And you should get 6 repeating, basically. So the A here is basically 0.667. I'm going to round it, so 0.66, okay? Here, if I type in 1/2 in the calculator, 1 divided by 2, I get 0.5. Remember, the negative sign does not matter to me because it doesn't tell me whether or not I have a wider or narrower. It just says that I have a reflection. So A here is 0.5. And then 5 divided by 4 in the calculator, 5/4, is going to be 1.25. All right, so now I have all of my A values written out so I can compare them with each other, right? Now, why is my A here so tiny? There we go. This one is 2. So now I have all 5 of my A values. I want to go from widest to narrowest. So I want to go from the smallest number to the biggest number because the bigger the number, the more narrow it's going to be. So where do we start? Well, what's the smallest number I have here? It's going to be this one. So that means this parabola is going to be the widest of all. So we have y equals negative 1/2 x squared goes to the first of the line, okay? The next biggest number I have is going to be this one, 0.6, right? 0.5 and then the next one will be 0.6. So this parabola is going to be the one that's the next widest, or not as wide, I guess. Not as wide? It's less wide than the previous, but it's still wide, I guess. Okay. Now we keep looking. Well, what's a little bit bigger than that? What's the next lowest number? Well, the next one is going to be 1.25. So it's going to be y equals 5/4. X squared is the next one. And then I have this one here, because that's the next biggest a value, y equals 2x squared. And then I have the last one, which is y equals negative 4x squared. Okay, so these are all my parabolas listed from widest to narrowest, and I'm going to show you what I mean by that. So I'm going to type these all in. Negative 1/2, y equals negative 1/2, x squared, and then I have y equals, I had negative 4x squared in there, I had y equals 2x squared in there, we had y equals 2/3 x squared, and then we had y equals 5/4 x squared. Oops. That x does not belong down there. X squared. Okay. So now I have all 5 of those written in. Okay. Those are all on our notes, right? All of them. But again, the negatives, all they do is just flip it over the x-axis. So if I really just get rid of all of those negative signs, whoops, undo. If I get rid of all these negative signs, I can actually compare their wideness and narrowness, right? So what's the widest of all? The blue one, which again is the 1/2 one. What's the next widest? The black one, which is the 2/3. The next one is the red, which is 5/4, the 2, and the green, which is the 4. So again, negatives have nothing to do with wideness or narrowness. These were a long set of notes. I'm very sorry, but transformations are something that's very visual, and so it can be hard for some people if they're not comfortable with it. So if you have any questions, just please feel free to come in for tutoring.